Hello everybody, and welcome to the last demo, which will showcase how a customer can take benefit from the analytics offered through Fame. In this scenario, we have again our customer, Bob, who is a representative of OMA Corp, a machinery manufacturing company that uses different sensors to gather information about its machines, temperature, pressure, vibrations, etc. He knows these measurements can provide some invaluable insights over his business, helping in improving their efficiency. He has heard stories about the perks of machine learning and AI and how they can help in, for example, detecting and/or predicting anomalies in sensors, but he does not have the expertise to explore that road, nor the budget to hire an ML team. He then remembers his subscription to the Fame marketplace, and decides to check if there is something there that can be of help. Through a search like the one we have seen before, he comes across the asset Alice published on behalf of her company, Acme Inc., which is exactly what he was looking for. Using the mechanisms shown in previous demos, he decides to purchase this asset. Once the operation is completed, Bob is able to download the asset and use it in his premises, thanks to the detailed instructions provided with it. Specifically, this asset is an application targeted to customers like Bob, focused on interpreting the data coming from sensors so as to perform machinery maintenance tasks. The application is composed by a front end, which is the only entry point for Bob, and where all the information is presented to him, a data importer module and an incremental database module, which are the mechanisms needed to gather the data from the sensors and ingest them to the application, an anomaly detector module, which is a machine learning model that identifies anomalies in the sensors, an explainability module, which highlights the specific sensor measurement that has triggered the alarm, and a CO2 emissions estimator, which provides an idea on the CO2 footprint of this system. As mentioned before, by following the instructions, Bob deploys this application in his premises, and starts visualizing these important highlights he was hoping for. In the following clip, you will take a peek at how Bob starts playing with the application and getting some interesting results. With the asset purchase, Bob obtains a Docker Compose YAML file that allows him to download and run all the containers, a process that is being shown right now in the screen. Once the asset is downloaded and running on his local machine, Bob can access the application on his web browser as follows. This is how the user interface looks like, where the sensor data will be depicted in the plot on the right-hand side. On the left-hand side, Bob can select the machine he would like to inspect, as well as the date and the sensor. Now you can see the temperature measurements depicted in the plot, which have been classified as non-anomalous. For demonstration purposes, let's now select a different machine and sensor we know were anomalous on that day. Indeed, you can see a suspiciously periodic pattern in the temperature that is deemed anomalous by the model. In this case, an explanation of the anomaly is also shown to the user at the bottom, which highlights in green the sample that caused the anomaly. Finally, it should also be mentioned that the application provides CO2 information to the user too, which is depicted at the top. You can see the CO2 per second, total CO2 and power drawn by the model for a single inference. With this we conclude the analytics within Fame demo. Thank you very much for your attention.